In this video, we are going to solve a previous gate problem related to damping ratio. You can see this problem. So, consider a system with transfer function g of s is equivalent to s plus 6 divided by ks square plus s plus 6. Its damping ratio will be 0.5, then the value of k is. So, the value of k we need to find out. They given the transfer function and here they given damping ratio and transfer function. When you heard the words transfer function and damping ratio, you need to consider the characteristic equation of the transfer function to get the value of zeta or omega n. So, here I am going to consider the general characteristic equation of second order system as s square plus 2 zeta omega n s plus omega n square, which is nothing but denominator of system loop transfer function. So, here compared to this equation, the denominator is ks square plus s plus 6. This will be the given characteristic equation. Denominator of loop transfer function will give you the characteristic equation. So, given equation is ks square plus s plus 6, you just mention is equivalent to 0 when you are writing like a characteristic equation, you just consider is equivalent to 0. I am taking common of k here, s square s by k plus 6 by k is equivalent to 0. So, s square plus s by k plus 6 by k is equivalent to 0. Why I am taking common of k is to compare with this equation. I need in this form s square term, s term and constant term. Now, I am comparing these two equations, fundamental characteristic equation and given denominator characteristic equation. Then I am going to get 2 zeta omega n is equivalent to 1 by k. I am just comparing s terms. So, here s term is s coefficient is 1 by k, here s coefficient is 2 zeta omega n. 2 zeta omega n is equivalent to 1 by k and another term is omega n square is equivalent to 6 by k. So, if you compare constant terms, omega n square is equivalent to 6 by k, omega n is equivalent to root of 6 by k. Now, coming to here 2 into zeta, damping ratio is nothing but zeta. Zeta they given as 0.5. So, that means 0.5 I can write 1 by 2, omega n is equivalent to 1 by k. So, 1 by 2 we can cancel, omega n is equivalent to 1 by k. So, by the comparison of s coefficients, I got omega n is equivalent to 1 by k. Here I got omega n is equivalent to root of 6 by k. So, now I am just comparing these two equations, 1 by k is equivalent to root of 6 by k. I am just squaring on both sides, that means 1 by k square is equivalent to 6 by k. I am cancelling k with this k square, then the value of k is equivalent to 1 by 6. By this, the value of k is equivalent to 1 by 6. Like this, we can determine the value, unknown value in the characteristic equation by just comparing with fundamental characteristic equation.